Really?
All right, so your problem was,
I just have a couple.
okay,
So let's do 17 then, I have not done 17. So I think I'm getting the same thing
Oh,
after.
me too.
Yeah, 17 week two.
Okay, so it's choose a domain that restricts the function. So it's f of x equals 1/2 x squared minus 2.
f of x is equal to 1/2
1/2 x squared minus 2. What is interesting? Sounds
minus 2.
Oh, yeah, I have.
Okay, so first, just x squared itself looks like this, right?
Yes.
1/2 x squared is going to be way wider, like that. And then subtracting 2, that's just going to lower everything by 2, right? So now we're like this. Now, what exactly, how is it they're asking the question?
Choose the domain that restricts the function f so that the function is 1-to-1 and has an inverse.
Okay. Well,
Yeah, I got negative infinity 0. I got that one and I got the next one. Do you have the next one?
No.
So the second one is for the domain selected above, state the range.
It's like -6, so. -6.
so there's two possibilities, right?
Mhm.
We have cutting it and keeping only the left, and cutting it and keeping only the right.
Okay.
Either case, we can keep 0.
Oh, okay.
Does that make sense? The reason why is because let's think about what I was saying before about inverse functions versus functions. If a function looks like this, its inverse function will be the mirror image of this, right? So that'll look like look that's that.
Yeah, so it goes down underneath.
Yeah. Like that. Kind of,
Okay.
right? Something like that. Makes sense what I mean? So here, what we're going to have when we flip it, in this case, it's a lot easier because our function looks like this. And our inverse function, if we can make it, would look like that, right?
Okay.
But everything over here fails, right? I mean, everything past this 0 fails the horizontal line or the vertical link test, right? So we're going to have to cut out either this bottom piece or that top piece. Does that make sense? What I mean? Similarly, we have what's called the horizontal line test, which tells you if a function has an inverse. Here, looking at the horizontal line test, fails everywhere except at 0. So the same idea. Does that help?
Yeah. It's like I'm wondering what maybe 2 infinity.
So I don't take.
Is it asking to restrict the domain of the inverse function?
In the range of the restricted function.
Okay, the range of the restricted function. So this is the domain. So this is the restricted domain of our function, right? All right. Its range would be from -2 to infinity. Agreed? But the domain of a function is the range of its inverse function. We're coming back to these values, right? So this is what's happening. We've got a function, let's say it looks like this. There's a point on this function. Great. The inverse function is going to take whatever this comes out to be and send it to 1. Does that make sense what I mean? So now we've got something right about here-ish.
So just, yeah, like when we find the inverse, don't we flip X and Y and solve?
Yes. Yes. So what this means, though, is that the domain of f of x is equal to the range of f inverse of x.
Okay, so then,
Because we're just swapping the values, right?
okay,
If the range is what your function sends your numbers to, then for f inverse to undo your function, it has to take the range and send it back to the domain. So that means for your inverse function, its domain has to be the range of your original function. And the range of your inverse function has to be the domain of your original function.
oh, okay,
So this is supposed to be the same as this, right?
yeah, so, like, the main up here is not gonna be from the ring. So this is a ring. Inverse, okay. So how would the other portion I'm doing is turning our main function and then creating it into an inverse function?
Yeah, that's my keep saying it's wrong. I don't know.
So that's good.
So the 1/2 x squared minus 2,
Turning that into the
turning it into the inverse function.
algebra.
How would we do that?
Yeah, because
Okay.
I
So
told it
walk
out
it
and it
back.
keeps saying.
All right, so first, this jives, right? This idea that the range domain flip, depending upon if you're looking at the function or the inverse function. So if you want to find the inverse function, first thing you got to do is figure out how you're going to restrict the domain and range if you need to, right? The second thing you're going to do, you're going to say, all right, what's my original function? In our case, it's this, right? Folks at home, we're still waiting on a couple people to show up. So bear with us. In the meantime, we are working on just looking at a couple homework problems. All right, so this is like step 0, just getting everything set up to look at, right? Step 1, swap x and y. So now that's going to look like 1/2 y squared minus 2 is equal to x. Step 2, solve for y. So coming over here, we're going to solve for y. 1/2 y squared minus 2 is equal to x. We know right away we can add 2 to both sides. So this implies that 1/2 y squared is equal to x plus 2. Well, now we can multiply both sides by 2. So this implies y squared is equal to 2x plus 4. Now we would take the square root. But we can't just take the square root, can we? The square root technically has 2 different parts, right? This tells us then that y is equal to plus or minus the square root of 2x plus 4. Now, depending on which restriction we use, will tell us if we want to use minus or plus. Because the graph of this thing, looks like this. This is the square root of 2x plus 4. And this is the negative square root of 2x plus 4.
So then it would be negative square root of 2.
Depending upon which restriction you used. If you used the restriction that the domain of f of x is from -∞ to 0, then you use the negative. If you use 0 to infinity, then it's a positive, right? Because this is telling you what your x values have to be to get these particular y values, right? So what this is saying is, you can imagine the inverse function as saying, given a y value, what does your x value have to be? But because we're pedantic, we want to use the same notation, so we write it as f inverse of x. But really that x represents the y in the original function, right? So this is going to send us back to all those negative values. Over here. And this is like that, right?
I have a question. Am I still saying, oh, no, it's fine now. It's just
Okay,
okay.
I did that too. It's what it's.
Okay, so never mind. If they'll draw it first, then I type it. That's fine.
But like I said, what's happening here is these negative solutions here are saying, all right, come over to our function. What we're putting through there are the y values over here. And what we're getting out are the x values over here, right? So the negative square root gives us all the x values on this side. And what the positive square root does is gives you all the x values. Cool. Does that help?
Yeah, and then I have one more, but we can wait until break if you want to start.
We can go ahead and run
Okay.
through another problem.
It's question 24. And I thought I solved it on that. This is
Okay.
it's find the limit if it exists. I can tell you the fraction.
That would help.
It's the limit when x is greater than 2.
The limit as x goes to 2.
Yeah, sorry. And then x squared plus 3x minus 10.
X squared plus 3x minus 10
over x squared minus 4.
x squared minus 4.
So then don't you find the like terms for the top and bottom?
Well, first thing you want to do is factor out both terms, right? This bottom one is nice because we can use that idea. X squared minus a squared is equal to x minus a, that quantity times x plus a, right? So for those at home who don't know, this is problem 17 in week 2, correct?
This is
Problem
this is
24. My mistake, this is problem 24 from week 2 homework that we're working on right now. So we're going to use this to factor out our denominator, right? And then up top, we're just going to factor it out like you normally would. All right, so this is going to give us the limit as x approaches 2 of x minus 2, that quantity times x plus 2, that's down in our denominator. In our numerator, this is going to factor out to be x plus 5 times x minus 2.
So then you cancel out, right?
Yep. So now we've got cancellation here, cancellation there. Yeah. So this is going to give us then the limit as x approaches 2 of x plus 5 divided by x plus 2. Now we can just apply the limit directly, right? There's no discontinuities here. But there was before, because if we put 2 in, our denominator gave us 0. So now we can solve this problem outright. This is equal to 2 plus 5 divided by 2 plus 2, or 7 over 4.
I didn't put in 2, that's why. I just have x plus 5 over x plus 2.
Cool.
Which one were you
This is 24 out of week 2. Having said
in? So
that,
you just basically factor in and cancel out what you can do.
Yep. exactly. And this is really just this is rinse and repeat type of a process. We're going to keep seeing this process over and over and over again.
And that's just basically that's a lot of algebra right there.
Yeah, it's algebra, and then keep that limit idea, right? So this limit is only really sitting here to say, all right, we want to know what's happening when x approaches 2. And when we simplify this, what we really have is a couple of different things going on all at the same time. We've got x plus 3x minus 10 divided by x squared minus 4. This thing's equal to x plus 5 divided by x plus 2. Everywhere where x is not equal to 2, right? Well, if that's the case, then we have a rule that we talked about last week, I think, that says the limit as x approaches 2 of this thing is going to be equal to the limit as x approaches 2 of this thing. So because of that, just keep the limit all the way through, simplify, same answer. Make sense?
Yeah.
Because these things are in fact equivalent. So as you simplify, you don't have to say anything new. Just have to keep your limit there.